What if I told you, for the first time in human history, we just watched a star create the most powerful magnetic object in the entire universe? Somewhere out there, a billion light years away from where you're sitting right now, a star 25 times heavier than our sun ran out of fuel, and then it exploded. But this wasn't normal. This explosion was at least 10 times brighter than it should have been. And then something happened. Something no one had ever seen before. Its brightness didn't just fade, it flickered 4 times, and each flicker came faster than the last, like a heartbeat speeding up before death. And figuring out why this happened just changed astrophysics forever. But before we get into that mystery, you need to understand one thing. What exactly is a magnetar? When a massive star dies, its core collapses in less than a second. Something bigger than our sun gets crushed into a ball just 10 miles wide. That's a neutron star. 1 teaspoon of it weighs about 1 billion tons. Let that sink in. Now imagine something even more extreme, a magnetar, a neutron star with a magnetic field so powerful it's almost impossible to comprehend, around 300 trillion times stronger than Earth's magnetic field. If you got within 600 miles of it, it could literally rip the iron out of your blood. Yeah, it's that insane. And when these things are born, they spin insanely fast, over 1,000 times per second, turning them into cosmic engines, throwing energy across space at unbelievable speeds. But here's the problem. We've known about magnetars for years, but we never actually saw one being born. Until now. Back in the early 2000s, astronomers noticed something strange. Some stars didn't just explode, they exploded way brighter than usual. These were called superluminous supernovae, about 10 times brighter than normal ones, and they stayed bright for months, which made no sense. So the question was, what's powering them? In 2010, a physicist named Dan Casson had an idea. What if at the center of these explosions, there's a newborn magnetar spinning insanely fast, injecting energy into the explosion, making it brighter? It was a brilliant idea, but for 16 years, there was no proof. And then, everything changed in 2024. In December 2024, astronomers spotted a new explosion, SN 2024 AFAV, about 1 billion light-years away, meaning the light we're seeing today started its journey when life on Earth was still primitive. Scientists tracked it for over 200 days. At first, everything looked normal. Brightness peaked, then started fading. Nothing unusual. But then, something weird happened. The brightness didn't just fade, it started wobbling. Up, down, 4 times. And here's the crazy part. Each time it happened faster than before, like a signal speeding up, a cosmic heartbeat. Scientists called it a chirp, and no one had ever seen anything like it before. So the question became, what could possibly cause this? A researcher named Joseph Farah finally figured it out. When the star exploded, not all of its material escaped. Some of it fell back inward toward the newly formed magnetar and started spinning around it, forming an accretion disk, like water circling a drain, but on a cosmic scale. Now here's where it gets insane. That disk wasn't perfectly aligned, it was tilted, and this is where physics gets wild. According to Einstein's theory of relativity, a spinning object doesn't just sit in space, it drags space itself with it. This effect is called lens-Thirring precession. Because of this, that tilted disk started wobbling, and as it wobbled, it blocked and revealed the light from the magnetar again and again, creating those brightness pulses. And as the disk moved closer, the wobble got faster, which is exactly why those signals sped up. This wasn't normal physics, only relativity could explain it, and for the first time ever, we had proof. So why does this matter? First, we finally confirmed that magnetars are real engines behind these extreme explosions, a 16-year-old theory proven. Second, we now have a pattern. That chirp is like a fingerprint, meaning we can go back and find more hidden magnetar births. Third, magnetars might be responsible for something even more mysterious: fast radio bursts, powerful signals from deep space that we still don't fully understand. And this discovery brings us one step closer. But maybe the most important part is this: a star died 1 billion years ago. It sent out a signal, a message hidden in light, and after traveling for 1 billion years, we were finally able to understand it. We live on a tiny planet orbiting an ordinary star, and yet somehow we can watch the death of a star across the universe. And understand what actually happened. That's not just science, that's human curiosity at its peak. Now I want to ask you something. What do you think is the most extreme object in the universe? Let me know in the comments. And if you want to explore more mind-blowing space discoveries, make sure to subscribe, because the next one might be even crazier.